Okay, let's have a look at question 3. There's two possible ways on doing this. I'll show you both. They both involve the same thinking, but just a little bit different. So we have this function x squared plus 3 to the power of 7. We want to find the term in x to the 5 in the expansion of the derivative. So the first way I saw it is I want to derive this function using the chain rule. That leads us to f of prime being 7 x squared plus 3 to the power of 6, but then multiplied by the derivative of the brackets. That is equal to 14x x squared plus 3 to the power of 6. Right, the bit that I'm interested in is here. Because we've got this 14x, I'm only interested in the expansion of this bit to get a 4, because I need to times it by 14x at the end. So I want x to the 4 from x squared plus 3 to the 6. That's the bit that we're actually interested in looking at. So that's going to lead us to 6 and r of x squared, 6 minus r, 3 to the r. Well, x squared, so that's 6x to the minus 6x to the r must equal 2, because x squared squared is going to give us the x to the 4 value that we're looking for, which leads us to r being 4. That's going to give us 6, choose 4, with x squared to the 2 and 3 to the 4. Now, here we can use the calculator to work this out. 6 choose 4 is 15. So we've got 15, 3 to the power of 4 is 81, and then we've got x to the power of 4. That's going to give us 1215 x to the 4, but we need x to the 5, and we still got that 14x. So if we multiply that, so multiply this by the 14x, that's going to give us 17,010 x to the 5. So the solution is 17,010 x to the 5. Where do we get our marks from this? So we're going to have, so using this method, we're going to get, I'll do the mark scheme in green. We're going to have A2 for the derivative. A reason 1, so an R1 for knowing that we need to find the x to the 4. So valid approach, so here, think the implication of the 4 is just isolating this, so this, the reason could also be here, that would also count. Here, this bit is going to be worth a 1. Correct working, so again, expansion, we're an A1 here, so that's 2, 3, 4, 5, 6, and then final solution being in 1. That's not the only way to go about this question, okay? So I've used the chain rule and then found the value of this one. The other way to go about it is to recognize if we expand our function, which is the original function, we want to find x to the 6, because when we derive this, so the function, if x to the 6 is the function we derive that's going to bring, we're going to be using the power rule. So let's just do what we've done previously. So let's go with, we have 7 values, we need to choose r, we have x squared to the 7 minus r and 3 to the r. We are looking for, well, we want this value, this 7 minus r times 2, we need it to be 6, so 7 minus r, sorry, must equal 3, which leads us hopefully to r being 4. So now we can substitute that in. We have 7 choose 4, x squared to the 3, 3 to the 4. Now if we expand that out, we end up with 20, using a calculator or whatever method you so desire, we've got 2,835 x squared. Now if we power rule that, we've got an implication that we're going to times by 6. We have 6 times 2,835 x, reduce the power down 1, times those out, again you're going to end up with this. Yes, if you really wanted to, you could expand the brackets out and then derive the middle function, but that's just going to take you too long. You've got 7 minutes. This video's taken 5 minutes, 15 seconds so far. So that's gaining us a couple of seconds. Where do you get the marks on this one, however? So let's do the answers in green. So this would be the first mark, valid approach to find terms in x to the 1. So here, this is going to be another one. Identifying correct term, here 7 to the 7, 3, 7, 4, same. Yeah, okay, so here we have an A1, here continuation of the A1. Correct term here, A1, so we're 1, 2, 3, 4, 5. Correct term, yes. Differentiating the term in x to the 1, 1. And then that leads us to an answer of this. If you show no working out and you only show 17,010, so the final answer being 17,010 x to the 5, you're going to score N3.